So here we have a sports store has jerseys representing the 7 Canadian NHL teams and then the 8 Canadian CFL teams. And then we need to pick 5 of the jerseys to display in a window. And the displaying it in a window, if I display anything, I'm making order matter, right? Because the display, I can see a difference if I move stuff around, right? If I put posters on a wall, that's also order matters because I can see the posters if they move. We agree? Okay. So here it says the store owner decides to choose 3 NHL and 2 CFL. So I need 3 NHL and 2 CFL. Now I'm choosing NHL from NHL, CFLs from CFL, so it's C's. I know that immediately because that's what it always is, right? When I choose drivers from drivers, irons from irons, defense from defense, forwards from forwards, girls, girls, boys, boys, principals, principals, students, students. If I'm choosing from that specific different thing, I'm going to have a C every time. So I know to get the 3 NHL, I have to choose from the 7. So I get 7C3. And then I get the 2 CFL from the 8. Now guys, what this C does, this 7C3 and 8C2, what it does is it gives me 5 jerseys in my hands. Here I'm holding 5 jerseys. So that's what that does. 7C3, 8C2, everyone paying attention? 7C3, 8C2 gets me 5 jerseys in my hands. Is that what the question asked me to do? They wanted me to get those 5 jerseys and then do what though? Display them. So currently, this 7C3, 8C2 just gets me the jerseys in my hands. Is everyone paying attention because this is important and people are going to be lost? So I'm currently holding these jerseys. What do I still need to do? Arrange them. If I took these jerseys, put them in a box and mailed them off, I'd be done, correct? Because the order wouldn't matter. I'd take all 5, I'd throw them in a box and I'd mail them off, right? But that's not what I'm doing. I'm getting the 5 jerseys by doing 7C3, 8C2 to get the 5 jerseys, and now I need to arrange them. So I need to arrange 5 of them. So I go times 5, times 4, times 3, times 2, times 1. Or I could go 5 factorial. Or I could go 5p5. I could multiply by any of these 3. They all mean the same thing. I think it's 17,100. I don't remember. What is it? That?
What?
171,000? I don't remember. Remember there being
117,600.
Pardon?
117,600.
17,600. Like I knew there was a 17 in it somewhere. Let's go on. This one here says there are 5 popular and 6 classical music compositions for the school. They want to make a program. A program has order, correct? Does a program not have order? So it's going to be a permutation in the end. But if I'm choosing classical from classical, popular from popular, I'm going to use C. I know that. If I'm choosing from the same thing, I have to use a C. So I'm going to go 5C3 times 6C2. And now I'm holding 5 classical and popular songs in my hands. Have I put them in any order? Have I put them on a program at all, or do I just have the songs picked? So now that I know what the songs are going to be, which 5 songs I picked from all of them, I now have to make a program with them, right? So then I have to times by 5, 4, 3, 2, 1. And that's how I get this. What is the answer to that? Did anyone get the actual answer? Pardon?
I got 18,000. I don't know if that's right.
19?
18,000.
18,000? Do we agree? Okay. I have, did I hand you the notes? I don't think so. I'm going to hand out the transformation notes. Actually, I'll hand them out tomorrow. I want you to we're just paying attention.
Yep.
So, can everyone put all their stuff down, pencils, pens, everything? We're just reviewing the grade 10 and 11 material we need for transformations. Okay? In grade 11, you would be given y equals a x minus p squared plus q, or sometimes you were given y equals a x minus h squared plus k. The textbook used P and Q. Grade 12 will use H and K, so it just depends on which letter they picked. But it doesn't matter what the letters are. Okay, all paying attention? So your teacher taught you that if you went y equals x plus, not, I'm going to do plus first, x minus 3 squared plus 6, we talked about the vertex, the lowest point, okay, or the highest point if it was reflected. The vertex came from here. Your teacher taught you that you took the opposite of this, which was 3, and the same as that, and you 6, and that was your vertex. So 3, 6 is where this parabola started. So your normal quadratic is 0, 0, and up, right? This one is 1, 2, 3, 1, 2, 3, 4, 5, 6. It's here. So what did my graph do? It moved 3 right and 6 up. Do we agree? 3 right, 6 up is what it did. Okay, why is it the opposite? And if you just said, well, because I just memorized that, that's a scary thing. Why is it actually the opposite and the same? Well, if I take this formula and I put it below, y equals a x minus h squared plus k, I have to match things with the letters. Everyone's paying attention? So, h, a, it doesn't exist, it's a 1. That does nothing to us right now. Then I have an x, then I have a minus, then I have an h. What does the h match here? The number what? 3, not the minus, not minus 3. I have x minus h. H actually equals 3. We agree? And k equals what? K equals 6. So that's why it's 3 and 6. Because the formula actually has this minus sign in it. Do you see that? So the h is not minus 3. The h is just the 3. So that's why we go 3 to the right and 6 up. That's why the k is always the same. There's no minus sign. What happens if I give you this, though? Y equals x plus 3 squared minus 2. Well, if I line my formula up underneath it, it's x minus h squared plus k, right? How do I get x minus? Well, I would have x, then what? The minus sign has to be there, right? They have to match. X minus, how would I get a plus 3 if I have a minus sign here?
Make the 3 negative.
Make a 3 negative. So I have negative 3 squared plus negative 2. We agree? You see that? So that's why when it's actually x plus 3, h is actually negative 3. That's why it's actually 3 to the left. Because this minus a minus that made that plus. Do you see the difference? So it's not the opposite because someone told you so. It's the opposite because the formula we start with has a minus sign in it. So in order to get a plus 3, we'd have to go minus a minus 3. And that's why we go 3 to the left, and then this is 2 down. It's just the same as what we had. We agree? Okay. Then in grade 10, if you haven't noticed, we go back to grade 10 every year. Every day of the year. In grade 10, you guys were first taught about function notation. So you were given linear equations. Y equals 2x plus 6. And then your teacher's like, oh, function notation. F of x equals 2x plus 6. And last year we even did it instead of y's. And your teacher said, oh my goodness, my eyes are watering. Your teacher said, don't worry, f of x is the same as y. Well, why do we even do that then? Well, because of this. If I give you a graph, so in grade 11 we did linears. That's the only graphs we did, right? Lines. Then in grade 11 we did 2 units on quadratics, a parabola. Then we did a little bit on absolutes and reciprocals. That was grade 11 graphs. Grade 12 graphs, we can do any function at all. So quadratics, cubics, quartics, quintics. That's degree 2, 3, 4, 5 plus linear. Then we do exponential graphs, log graphs, trig graphs, which is sine, cos, and tan. We do radical graphs, rational graphs, and any function graph that could be out there. So a function is anything that passes the vertical line test. So that means for every x, there's only one y. So if I drew vertical lines through this graph, it would pass, right? So I can move that graph too. It's a function. It doesn't have an equation, but it's a function, so I can move it. The only restrictions I have on myself for functions is It needs to be a function. And polynomials, it has to be less than degree 3, 5, or less. That's the only restrictions I have. I can throw any function on the board and make you move it. So why would they teach you about f of x? Well, you've only ever had a graph on a graph. What happens if I give you a linear, a quadratic, and a cubic on one page? Which one's f of x? Which one's y? Is there any discrepancy for any of these graphs? What if I do this? What if I go f of x, g of x, h of x? Now do you know which one's f of x? Now do you know which one's g of x? Now do you know which one's h of x? Yes, it makes a big difference. That's why function notation gets brought in. Also, what they'll do is they'll give you y equals f, x minus 3 plus 6. This just tells you, this has an f in it. Do you see that little f? There's no little f button in your calculator. This can't get plugged into y equals. This is the same as if I gave you words. Now this is affecting the f graph. That's why the f is there, because I have an f, I have a g, and I have an h graph, correct? This is affecting only the f. What is this? A horizontal translation what? 3 units to the right. And this is a vertical translation what? 6 units up. So instead of them giving words, instead of them saying, okay guys, I'm moving the f graph, the f of x graph, 3 units to the right, 6 up. They'll say, okay guys, these are the transformations happening. Move the graph. They're just not giving you the words. And how do we know it's affecting the f graph? Because there's an f there. So if I want to move the g graph, they might say, okay, move the g, I want you to do this transformation. Now what graph am I affecting? G. And I'm moving G what? A horizontal translation 4 units to the right and a vertical translation 3 units up. We agree? So if I have the coordinate xy, this is mapping, if I had the coordinate xy, it would become x what? How do I move it 4 to the right? Would I add 4 or subtract 4 to it? Not a trick question. 4 to the right. Would I add 4 to x or subtract 4 from x? Moving it to the right. If this is the coordinate, I need to move to the right. Am I going to add 4 to it? Add 4. And then if I need to move it 3 up, I'm going to do what to my y? Plus 3. That's a summary of all the stuff you've learned up until this point that we need